Hello, everyone. Welcome. Thanks for joining our diagnostic training session today. Now, if you have any questions throughout the session, if you're joining us on Zoom, look at the top of the bottom of your screen. Wherever your Zoom controls are, you should see a little button that says Q&A. Click on that, hit submit, and I will get to those questions at the end of the session. If you're watching live on YouTube, just make sure you use the live chat function in there, and you can just utilize that. I'll read through the questions and comments at the end as well. Also like to shout out my friend Ephraim down in Harrisonburg, Virginia. He's got a class in, piping me in live as well. So I'd like to shout out to you guys. Thanks for attending. So my name is Jason Gabrinas. I'm one of Snap-on's national diagnostic technical trainers. Been in the training department the last 9 years or so, traveling around North America, helping techs and shop owners get the most out of their diagnostic equipment. Before I did that, it was a couple years as a diagnostic sales rep at Snap-on. So I had about 30 different Snap-on franchisees I worked with, as well as the shops that they serviced, in order to help everyone get the most out of their diagnostic needs. Then before that, it was 8 years at Subaru. So I worked in a Subaru dealership, and over time, I guess, just became the default diag guy in the shop. So I always had the drivability problems, the intermittent problems, the weird wiring problems that would show up on those cars. And that's really where I cut my diagnostic teeth and learned a lot about diagnosing vehicles, was in that shop doing that hands-on sort of thing. Then before that, bunch of other miscellaneous wrenching jobs. Been a little over 25 years under hood experience for me. So our topic at hand today is going to be component testing, and this is part 2. We started part 1 last week talking about why I need to test a component in the first place, and then also talked about, well, how do I test a single component, single channel? Let's see what this signal is doing for us, or what it's not doing for us if it's not working correctly. So for this portion of the class, we're going to talk about a case study. So we have a Subaru here with a flashing check engine. So the customer complaint is under hard acceleration, such as maybe merging on a highway or climbing up a steep hill, steep grade, 100% throttle, 100% load on the engine light would flash. Cruising normally, though, if we're hanging out in the left lane or whatever, just part throttle, 65, 70 miles an hour, whatever it happens to be, no engine light present at all. No other drivability concerns with the car. Even when the light is flashing, the customer doesn't even notice anything's going on. It's just they see the lights flashing, and that's concerning for them, and I can imagine why. So what is a flashing check engine light? It's a catalyst damaging event, usually a misfire when that's concerned. So we got to take a look and see. Let's diagnose this vehicle and see what's going on here. So the first thing we're going to want to do on any vehicle, if we have the ability, is we want to be able to code scan, do a scan of the entire vehicle, check the whole vehicle for codes, see if there's codes in other modules that don't have lights with them or something of that nature. So we see right here with the engine, we got history codes, we got a cylinder 3 misfire in history, and that would be why no engine light on. It's in history, it already happened, but right now it's not going on. So it was in the history, and they'd driven it long enough to get it out of current and into history. So cylinder 3 misfire. So we'll select diagnose here because we were using this on a Zeus, and that has fast track intelligent diagnostics. So that should help us out a little bit when it goes to diagnosing the problem. So you can see here's the landing page, and it looks like we have 4 TSBs. Now we want to use the fast track intelligent diagnostics page like a book. It's going to be a repeatable diagnostic workflow. So top to bottom, left to right, I want to be able to touch on everything on this screen, and it's going to walk me through a diagnosis. So first thing first, top left corner, it's going to be my TSBs. There's 4 of them. So we're going to click on that. And we see we got a couple different ones. We got this one that says difficulty starting, rough idle, cam position, or misfire codes. We got a bunch of P03 codes that this relates to, a bunch of vehicles this relates to. So let's choose that one. And then we'll see it 2013 Legacy and Outback, 2012 through 13 Impreza, and so on and so forth. This is a 2011 through 2014 Forester. It was actually the first year of that engine, and they put it in the Forester in 2011. We read down below, it says this bulletin provides inspection and repair procedures for intake and exhaust camshaft position related and or engine misfire related DTCs for the FA and FB engines, which are going to be these engines we're talking about. They're newer chain drive 4-cylinders. FA and FB engine equipped models listed above. The cam position sensor clearance may be out of specification causing these conditions, and one or more of the codes listed above to set. So that is a key phrase right there. Camshaft position sensor clearance may be out of specification causing these conditions. So you might be thinking, well, what in the world does that mean? And why in the world would it cause a drivability problem or misfire or something like that? So here's a close-up look from further on in this bulletin as to what it looks like. So here's the cam sensor. It's got just the connectors up there. It's got one bolt that holds it into the timing cover. Got the timing chain cover right here. We got a little rubber O-ring, which sits in, and then it has this metal disc on the end of the camshaft that it reads. So it's going to have different notches in there, depending on what cylinders where. And you notice that there's an air gap right. So under normal circumstances, this is our sensor right here. This is our wheel. So it's going to have 3 notches and then a blank or no notch. The cam sensor on this vehicle is going to be a Hall effect type sensor, and it's a 3-wire sensor. So it's going to be put out a digital square wave in this case. It's going to have power, it's going to have ground, and it's going to have a signal that goes back. So when it's powered up, it is going to generate a magnetic field. Now, this isn't 100% what a magnetic field looks like. I can't really draw in 3D. But you kind of get the gist. We have these loops and these waves in here. So it's a little coil of wire. We run electricity through it, run current through it, and it generates a magnetic field. As it turns, as that disc disrupts that magnetic field, it's going to create a pulse. So there's my pulse right there. And judging on where this pulse is and how that pulse lines up, that's what creates the signal. And that's what sends the signal to the computer that says, okay, here I'm on cylinder 1. Cylinder 2, what cylinder needs to fire 1? However, this is if all is well and good. However, if we shrink that a little bit, we get it a little bit closer. Now the air gap is too tight, and you notice how this outer ring here, just like I said, it's just a drawing, an example, but you notice how it's intersecting that disc in a different way. So it's causing that magnetic field to change in an unexpected way. And the computer freaks out a little bit and doesn't necessarily know what is what and what's going on with the vehicle. So how do we figure this out? How are we gonna test this? Well, we're gonna want to test the component. Now, in this bulletin, you read through it, one of the first things it's going to show you is this pattern. Now, this is on a Subaru lab scope, but any lab scope with 3 or more channels will be able to show you the same. Channel 1's a crank sensor. Sorry, that's an analog sensor on this car. It's still a Hall effect sensor. It's going to have an up and down analog. On channel 2, it's going to be the right side cam sensor. Channel 3 is the left side cam sensor. So it is a horizontally opposed engine. So we have 2 cam sensors. If you look right here, there's a double gap, a single gap, a double gap, a single gap, and so on. So on one side of the crankshaft, it's got 2 pieces missing. And on the other side, it's got 1 piece missing. So that's way the computer knows I'm on top dead center or on bottom dead center, or 360 degrees or 180 degrees. Sorry, 180 degrees off. So it's either one side or the other. And then you'll see there's a gap. When I have a double here and a gap there and a single there, that's one combination. If I have a single, and a gap, that's another combination. If I have a double and two gaps or 2 blips, that's another combination. And a single and 2 gaps. 2 blips, that's another combination. So based on these combinations, the computer knows when to fire what cylinder. So if I see this one, I fire this one. If I see that one, I fire that one. If you were to draw a straight line through all those, I think you'd agree that they all line up. So this is a rare instance where a manufacturer actually decided to provide a known good cam crankshaft correlation waveform. Doesn't always happen. When it does, it's a wonderful thing because then we don't have to go searching. Go a little bit further down into the document, and then it gives you this pattern. Now you see it's only on 1 cam sensor. You see I got the regular blips, and then I got this big one right here, and I got this medium-sized one there, and I got this little bit bigger one there. But the 3 regular blips still show up. You'll also notice on this larger blip, that is getting into where there's supposed to be a gap. So according to what the computer's seeing, it sees single blip, blip, double blip, blip, single blip, nothing, double blip, blip again. So it doesn't know what cylinder is what. So it gets confused and it just fires the same cylinder multiple times, or it doesn't fire other cylinders because it doesn't see that. So that's a problem. And that's why we would have this issue. So next thing I want to do is, well, let's hook it up and let's test it and see if this car has this problem. So we're going to go into guided component test. And you'll see they do list a crank sensor, cam sensor, and ECM, and so on. The nice thing about Fast Track Intelligent Diagnostics is it narrows down all the tests on the vehicle just to the couple sensors that might be what we need. So first I want to check those cam sensors because we said the gap is close. So if we see that pattern where the gap is off, then we'll know we have a problem. So we're going to go in here. We could read component information about how it works, but I just kind of told you how it works right there. So we're going to go into the signature test. In the signature test, you take a look and it may look good or it may have a gap, right? In this case, this one does not have that problem at this time. So we see we have a blip and then a gap in between. So it doesn't have that problem. Let's look at the crank sensor 2. I'm going to pull that up. And then we see the crank sensor looks normal as well. We have a double gap, a single gap, double gap, and then we have that analog pattern back and forth. Now I want to be able to compare the two on the same screen. So we can do that as well. If we go up to the meter, click on that, and open up, makes it a little bit bigger. If we come down here on the bottom, we can open up the extra channels where we can open up more channels on this scope. So you can see I have 3 right there. Going to open up. Now I have my 2 other cam sensor channels there. So I have a crank sensor on channel 1. Channel 2 is one of the cam sensors. Channel 3 is the other cam sensor. And I can see how they line up. So I have a single, a gap, a blip, single, blip, blip. Could also do this on a 2-channel tool. This is on a 4-channel tool on a Zeus. But I could do this on a 2-channel tool as well. I just have to look at one cam sensor at a time. So if we know we're looking at a cam sensor problem, we can do one cam sensor at a time or both cam sensors at the same time, just without the crank sensor, making sure everything lines up. We can do that too. Went one more step further because I wanted to be able to see one single pass of the firing order. So I added an injector. So the injector fires lined up with all of these things. So if I use that 4th channel as an injector and with the trigger point on that, it's going to base everything off of that time-wise. And that's one of the important things. If I'm using multiple channels on a scope, I want to have them all on the same time base because I want to be able to see and compare and not throw my brain off, I guess, if I have different time scales going. So when you're comparing multiple channels, you want to have the same time base on all of the channels in order to have that comparison and not have it skew your information. We can take it one step further even, and we can separate them out, kind of like Subaru had it already. So we have the crank sensor there, one cam sensor there, and then my injector pattern is going to be right there. I could take it even another step further if I wanted to and open both on the same screen at the same time. If I have a Windows-based tool, I can open the cam sensor on one side. I can have my information on the other side. So in this case, we have our TSB still open up, and we can do that all on the same screen, all at the same. So that is the use of using multiple channels. Now I'm going to back up here a little bit. So we tested it and we tested to see how it worked. And how do you fix it? How do you fix this problem? And I shouldn't just leave you hanging and say, hey, here's how we figure out it. Here's how we figured out the problem. We don't how we fix the problem. So what happened is this was the first year of that engine for Subaru, as I said. And what happened is when they machined those surfaces on the cam or the timing covers, they machined a little too much off. So it brought that a little too close. So what we do is if we have that problem, while it's idling even, we do some measurements. We measure some break out your depth gauge, do a few different measurements. There's like 8 different part numbers of shim. Take the right shim it out, torque it down, double check with the scope. If the pattern looks good, then you're all set. All for one of a little $6 shim. And they were in like 1 millimeter increments, how thick they were, or tenths of a millimeter increments as to how thick they were. So it wasn't a ton of thickness difference. If it was super close, if the gap was very, very tight, you'd have starting problems, lots of drivability problems, hard stop problems. In the case of this vehicle, what happened is it was just barely on the edge, like it needed a 1/10 of a millimeter shim. Under a load, when things move, it gets a little bit closer and it throws the problem. When I'm driving down the road on just a part throttle, it's got the right gap. We don't have the problem. So at the just right on that edge, if I have enough stuff moving in the timing chain, you know, because we got things moving around and forces and moving around, it gets a little bit too close under a load. Not under a load, it's fine. So in this case, that's what happened. You put a 1/10 of a millimeter shim in there, you go. But I just thought that was kind of an interesting, good example of multiple channels and how we would use that. So that's what we're going to talk about now, is how to do that. Also, stay tuned. If you tune out during the live walkthrough, you're not going to learn about a contest that we're running. And it's a pretty awesome contest, if I do say so myself. I wish I could win it, but I can't. So we're going to talk about that after this live portion. So stay tuned. So let's see, what can we do? Let's go on the scanner. And I already have my Forester pulled up. I'm going to simulate the same situation. And you see there's my Fast Track Intelligent Diagnostics. We got a PL303 cylinder 3 misfire code. And scroll through and see all the information available. In this case, now we have 5 TSBs. So back when we did the case study, we had 4. Now we have 5. We're going to go in there, and you can see there's that same difficulty starting rough idle cam position. Pull that up, and we can scroll down, and then you see we have these different part numbers of shim. So 1/10 of a millimeter up to 8/10 of a millimeter. And that's the gap that we want. It's about a 1 1/4 to 1.35 millimeter gap between the cam sensor and the piece of metal down there. Special tools I need: depth gauge adapter if I need it, or if I don't have certain things, I need the washer there. There's my known good pattern, and it talks about this double gap and the time window that we need to have a pulse occur. So that's where we said if it got screwed up. Right now, it's pulsing the way it should. So it would be 1, 3, 2, 4 is the firing. So if it sees a certain combination, it's going to fire that cylinder. So if it sees a 1, a yes, and a yes, then it fires number 1. If it sees a 2, a no, and a yes, then it fires number 3, and so on. When we have the problem, we see we have the erratic signal. So we have this extra signal there. So it should be shooting 3, 2, 4, 1, 3, 2, 4, 1. But instead it's 4, 2, 4, 1, 4, 2, 4, 1, not even firing cylinder 3, and it's getting the signal to fire cylinder 4 twice. That's why we have a misfire problem. It appears to be erratic, but it's not. In this case, it looks like it's erratic, but it's still okay because it's just outside of the window. So it still works. It's still not right, but it's not bad. And if we come down here, we can see the cam sensor, and we can see the shim where the shim gets added in there. Make sure that our depth is correct. Position to the plate. There's the notches. We want to take the depth to, not the notch. We want to take it to the other way. Going to tell us how it works. Do a little bit of math. And so on and so forth. So it gives us the time down the bottom. All right. So here's my known good pattern. Now I want to be able to have this on the screen, and when I'm done and going through all this procedure, I want to be able to have my cam and crank pattern on the right-hand side so I can see that going back and forth. So to do this, since I have a Windows-based tool and my TSBs are in my scanner, I'm going to leave that going. Go to the home screen, go to my guided component test. Load my vehicle, I'm going to engine. Once I load the engine, it's going to list all of the components or subsystems that I can test. In this case, I want to start with the crank sensor. Crank sensor, if we look at component information, it's going to tell us it's a magnetic pulse generator that outputs an AC voltage. As engine RPM increases, frequency and amplitude increase. Sensor provides RPM and crankshaft position of the ECM. Back up a little bit, and we go to the signature test. So we connect yellow to crank positive, black to crank negative, and it should swing -7 to 7 volts or more, depending on RPM and such. So we're going to open the, we're going to have our sensor go. And we see it's about 7 to -7. There's my crank sensor. I see a single window. I see the double window. Everything's there. Everything looks the way it should. So it should swing -7 to 7, or about -7 to 7, maybe a little bit over, but that's okay. That's where what it's supposed to be. All is good here with the crank sensor. Let's add in the cam sensor. So we go up to meter, turn it up, makes it a little easier to see. Come down here on the bottom, going to expand our information here. I want to turn on a couple additional channels. So cam 1, cam 2, there's my 2 cam sensors. Now you see I have 1 cam sensor up there, but what's going on down here with this green line? Why don't I see that? So what it does is the guided component test will automatically set the scale for whatever you're testing. Everything else is going to be wherever it is when the preset was saved. So in this case, channel 2 is set to 400 volts. So I need to change that down to more like 20 volts to match this cam sensor. So I'm going to click on that, change it to 20. There we go. Now I can see they're kind of flipping by. They're kind of lined up. Got a lot going on here, though, because normally it's probably going to present itself more like that, and it's going to be a little hard to see what's going on. Got a lot of stuff on the screen, a lot of stuff going on. So next thing I want to do is add a 4th channel and add that. In this case, we'd add, say an ignition coil or something like that. So this is just a square wave pattern. I could put a injector on there if I needed to as well. But this is what you want to do when you're doing this. You want to find one pulse that happens once in each firing. So that way I can line everything off the back end. We look over here, we see the slope, and I see it's catching it on the yellow channel. I want to move that to the red channel. So I'm going to come down here and just click on it that way. And now you can see it's catching it on the red channel. If I move it around, my whole pattern's lined up. It moves accordingly. If I wanted to move it over here to the right, we can do that. Whole pattern moves accordingly. So in this case, I want to see one time in the firing order. So I'm going to put it over here on the left. We're actually in a little bit. But that's okay. So we can see that's where the next one's going to fire over. So I can see the pocket here, the pocket there, the pocket there. See all 4 firing at the same time. Now, once again, a little difficult to come in here. A lot of stuff going on, a lot of different colors, and they're kind of blending together. So I'm going to clear this out so I don't need to make any changes in it. I go up to setup and I go to view and I go to layout. I can set it to have 1 window, which it is, 2 windows, 3 windows, or 4 windows. So I go to 4 windows. There's my layout that I was looking for before. So I have channel 1, channel 2, channel 3, and then my 4th channel for a trigger. We also wanted to, you can turn the cursors on. Make sure everything lines up. So that all lines up there. That all lines up within the window as well. It's supposed to be before that gets all the way down to the bottom. So that lines up in the window. And then same with over here. Everything looks good. The pattern looks good. So in this case, the car would be in good shape for that. So that's a kind of a little bit more advanced take on how I would look at things. Cam and crank correlation. You can do this for fuel injector, current, amperage, and pressure. We've done that before on one of our classes. So you can see how the current flows versus the amperage and the pressure. How about looking at in-cylinder pressure? You're going to see the compression event with the pressure transducer. You can also add in a coil to see where the coil is firing as well. So you can see where the top dead, how it fires before or after top dead center, and so on and so forth. So using multiple channels is definitely helpful when it comes to getting these comparisons, especially these time-based comparisons. If one of these camshafts was one way or the other, it's either advanced or retarded timing on that one camshaft, because we can have variable valve timing problems that we could diagnose this way. We can see, is it shifted to the right? Is it shifted to the left? Which way is my timing belt or timing chain stretched, timing belt stretched? Any of those options can be done or can be looked at by using multiple channels with a scope guided component test meter. Now, one more thing we wanted to say, we wanted to have this on the same screen at the same time. Once I got it set up here the way I want it, I'm going to go up to meter again. Makes it a window. I can then go back to my scanner. I can see this on the left. I'll pull up my taskbar down here on the bottom, pull up my scope, snap it to the right, snap it to the left. And then we can see here's my known good on the left. Here's the pattern I'm getting on the right, and that pretty much looks the same. So I can compare, here's my known good, here's my what I'm currently getting on the car. All looks good, all is well. So with that, that's talking a little bit more about our advanced. Let's take it to the next level. Let's add another channel, add another couple channels, add another 3 channels. In this case, is how we got to it. So hopefully you learned a little bit more about why we would want to do that, and a little bit more about how to do that if you have the right tool for the job. You also could do it on a separate scope. If you had a separate scope and scanner, you could put them right next to each other and have the information that way as well if you wanted to do it that way. So a lot of ways to skin a cat. It's just seeing, here's how we can do it. Here's why we want to do that. Why would I want to use multiple channels with that, with the component testing as well. All right. So that's my time for this evening. This one's a little bit shorter just because it's the second half of the first one. All right. Here's the big announcement. If you haven't heard it already, I think I announced it last week too. But you can get, if you have a Snap-on scan tool and you're in North America, sorry UK, sorry Australia, sorry anywhere else. But if you're in the US and Canada, you could win this box. You could win this workstation. Anyone that upgrades to version 22.4 by the end of the year, so that'd be whatever, that's the fall release that just came out 2 weeks ago. As long as your tool is running 22.4, it'll say 22.4 on your home screen. As long as it's running that by the end of the year, you are entered to win. So depending on how many people do that is going to be what your odds are. Also, however many people do that in your region, because we are giving away 10 of these. 10 of these. One for each region in the US and Canada. So Canada is its own region, and then the US has 9 regions itself. So one per region in North America. Retail price on this thing's $24,000. It's a 36-inch Epic work center. So it's got the work center on the top. It's got the hutch on the top. Inside the hutch is going to be a Zeus Plus, a brand new Zeus Plus. And then it will also come with the docking station and a 27-inch touchscreen monitor in the back, so you can actually operate the Zeus Plus from the touchscreen if you wish to do so. Also have the nice big screen to watch and look at if you're across the shop, in the car, that sort of thing. So this is our new top-of-the-line Epic workstation. So you do have an opportunity to win this as long as you have a Snap-on tool that can take 22.4 software. You can get it updated and you're in the running. Also, your name gets put on it too. So it's going to be personalized with your name on that drawer right there. So that's kind of cool as well. So it's going to be one of a kind, one of a 10 items. So like I said, really easy to enter. If you are on a software subscription, which many of you are, just update your tool. Simple enough, right? It's already available. Many of you probably already have. If you have a prepaid data plan and it's still current, just update the tool. You can go on the web, it updates by itself online. So as long as you do that, and as long as it's in there by the end of business on December 31st, 2022, we'll run a report the next week and we'll see who was there. And then you get into a random drawing to win this gorgeous Epic workstation. So I think that is pretty cool. Let's talk about next week. So next week, we are going to talk about diagnosing intermittent issues. Always a problem. We're going to walk through a few different things, a few different items that you can use both in your scan tool and in your scope in order to help you diagnose some intermittent problems that might not necessarily have a path to go down. These are the hardest ones to look at. So we're going to look at things like fuel trims and freeze frames and things of that nature. We're going to talk through a bunch of different things that we may be able to do to help us with diagnosing intermittent problems. So hopefully you can join me next week, same time, same place, 6 and 9 Eastern. If you want to join on Zoom, go to snapon.com/OT. On YouTube, you can go to youtube.com/Snap-on Diagnostics. That's 6 p.m. Eastern class gets live streamed there. The 9 p.m. class gets live streamed to my Facebook page. So if you are on YouTube right now, make sure you like and subscribe and ring the bell, just so because that helps us out. The more subscribers we have, the better content, more content that we can do for you. So definitely want to check that out if you're on YouTube. And actually find out the majority of the people who watch the videos don't subscribe. So it'd be a good idea too, so you can know next time we put out some video. Also, if we want to see some of the older content that we put out already, or past previous content, should I say, things like ADAS, code-based diagnostics, data bus testing, hybrid vehicles, VVT, automatic transmission, all sorts of different 50 different courses now, all available for free, archived on our YouTube channel. So once again, youtube.com/Snap-on Diagnostics, and check that out as well. So now it's time for questions. If you do have any questions and you're on Zoom and you join late, just look at that Q&A box, type them in and check it out. And Ephraim, if you have any questions in the room, just type them into the box there and we'll get them answered. I do want to also mention my buddy Al, though. So Al also does free training. He does free diagnostic training on specific scan tools. So Monday, it's on Apollo. Wednesday is on Zeus. And Thursday is on Triton. So if you want to join those classes, it is a very thorough class. The first hour on any of the classes, they're going to be on their respective tool. But it's going to be, let's make sure your Wi-Fi is hooked up, because a lot of people struggle with that. We're going to help you out with that. Let's set up your free Snap-on Cloud account so you can share files with your customers, upload files. And then we're going to walk through a real-life scenario, code to completion, using Fast Track Intelligent Diagnostics to show you how this helps the technician Diagnose cars faster and easier. So that's the first hour on any of the classes. On Wednesday and Thursday, since the Zeus and the Triton also have scope built in, he's going to take a 5-minute break after the first hour and then go through another hour. Scope, meter, some real world examples there, a couple different tests that you can do and take into the shop right there the next day. So if you want to check that out, once again, it's free. Same time, same place, 5 and 8, 6 and 9 Eastern. Snapon.com/OT to reserve your seat there. He does not stream to YouTube or Facebook. He just does it on Zoom, so you can have a little bit more of that. Ask your questions, get them answered. It's a little bit more of a back and forth in that class, so you can kind of walk through it with him as he's going. So definitely check that out. All right, time for questions. All right, Harrisonburg, looks like we are clear. Thank you very much, Ephraim. Thanks, folks, for tuning in. Hope you hopefully got some good information about that. And I'm sure Ephraim also has some other good information for you after we are done here, no doubt. Let's just check YouTube here real quick. So the Winton, hello, welcome as always. Nick from the UK watching at 11 p.m. at night, just about every single week. I really appreciate that. Quinn Hall coming to us live from Race City, North Carolina. So down in North Carolina, NASCAR country. I am sure that's what Race City is referring to. Abel Gracita, thanks for coming. Thanks for watching. Herbert, and thanks for watching as well. Nick loves his Snap-on Zeus and nothing but great compliments. And Nick also says he can't wait for the Zeus Plus to be available over in England. Like I said, I'm not sure yet when that's going to be. At the earliest, I would imagine sometime next year, if not later. So just be on the lookout for it, I guess. But as you know, we always get stuff over here first. So, can't wait for you to get it over there either. It's a wonderful tool. I love it. All right, so with that, that is all the questions and comments. So I'd like to thank everyone for joining me. Hopefully we learned a little bit more about a little bit more advanced guided component testing use. We can add channels. We can compare things across channels in time. We can also do screen and screen to see what's going on, both on the scanner side and the scope side. So hopefully it's, excuse me, has some good takeaways there. Hopefully you can join me next week for the intermittent problems course. With that, enjoy the rest of your week. Enjoy your weekend. See you next week. Take care.